Well, the second part of the advanced CAM design is after you have the profile, continue with the components to create the simulation. Here, this was last step from the part one, so I suggest you to close this part. Make sure you don't have any other part open, and go to the folder that you have the NX part of the profile, and I suggest you to create a new folder for the CAM design points, where you can move the text files, and then you're going to create the skeleton, copy and paste the profile, and you add on this point the skeleton name. Key point here is that and change it to 00. Key point here is that we are doing it from this point to avoid what happened last time when we had the profile of the CAM. We created a solid from that point, and then we tried to create a skeleton from the sketch of that file, and we couldn't import the skeleton to an assembly because the NX didn't show the skeleton into the assembly. And then go to Blackboard in CO6 Advanced CAM Profile. Double click on Advanced CAM Components, and then download the follower support in Shaft. Make sure you are using it. You are using Internet Explorer. Right click on followers, save target as, and then locate on your desktop. Okay, let me see. In my case, it's 52 CAM design, and remember, have to delete any extra number or parentheses or whatever it is created when you save these components. Save target as. Okay, delete support, and then save target as, and then Shaft. Okay. Make sure all of the components are on the same folder. Otherwise, it will be kind of difficult to create any assembly. Open the skeleton. Okay. And then let's create a sketch. This sketch will be exactly on the XZ plane. Okay. Unselect continuous auto dimensioning. Create a line from the end point of the horizontal line. Click on it, and it has to be the measure of the radius, linear dimension, of the follower. In this case, has to be 0.2 inches. Convert this to reference. Create a circle, and the dimension of this circle is 0.4. Okay. Then a straight line from the center of the circle to your right, and the dimension of this one is 3.5. Then another circle, radial dimension, and that one will be 0.35. Okay. You already have your skeleton. Finish sketch. Save it. And then go to menu to make sure which ones are the files that you have opened, and there is only the skeleton. File, open, and open the CAM profile. Okay. Then we can start working on the solid. Go to from view, and then create a sketch on the XY plane. And unselect continuous auto dimensioning. Create a circle that has to be radial dimension of, let me see, 0.5, and then vertical line that has to be 0.25, 0.3. Select, convert it to reference, and then go to offset curve, select the vertical curve, in 0.075, 0.075. Okay. On a straight top line, and quick trim. Okay. Closed. Finish sketch. This space is for the shaft. Make a trimetric view. Go to extrude. Select connector curves. Symmetric value. 0.15 is okay. First, select these curves. Okay. You see it is creating a solid, but now you select profile, and now we have our CAM. Okay. Then hide, show and hide curves and hide sketches, and use edge blend, and make sure you have face edges to select both sides of the CAM. Then you already have your CAM. Okay, go to view, edit object display, select CAM, and the color has to be ash gray. Okay, okay, save, view trimetric. Okay, once you have this CAM, we have to create an assembly. So go to File, New, Assembly, and make sure you go to the folder, the same one you have been using. Otherwise, you're going to have a lot of problems to save. So in my case, okay, CAM design, and then the name is 05_CAM design ASY as an acronym of assembly. And the first part that you have to add the component, it's the skeleton, absolute origin. Make sure you go to assembly constraints, fix, select. You see this is a symbol of fixing. Save, add component, cam profile, absolute origin. Okay, now you have your cam. Okay, once again, I suggest you to fix it also. You see this is a symbol of fixing. And then let's add the follower, the support, and the shaft. Add component, go to folder, to open the folder, and then select follower, absolute origin, it's okay. Move component, left click on the follower and middle click. And you see, once you click on the middle over the part, you see this axis, and you can drag whatever you want or rotate as you want. With your left click, drag the follower here, okay? And then assembly constraints, touch align, invert center axis, touch on the circle, touch on the circular surface, and you already have it. It's a little bit bigger, isn't it? So we can make a correction later. Then let's work with the support. We can go to the shaft. Shaft. Okay. Absolute origin. Move component. Click on the component. Middle click. Drag. Okay. And see, you can do two things here. The assembly constraint could be related to this circular surface, or you can go to view and then static wireframe, so you can see the circles here, and then home, assembly constraints, touch align, touch the circle from the skeleton, and touch this surface. Okay, now you can return to the shaded view, and then you have this. Okay. Okay. Let's go to create or to assemble the support. Open support. Okay. Okay. And just the same. Move component, click on the shaft, middle click, and drag it. Okay. And just the same, because this follower is hiding the skeleton, we can go to view, static wireframe, home, assembly constraints, touch align, invert center axis, very important. Touch this circle that corresponds to the skeleton, and you can touch any internal surface, circular surface. Example, this one. Face. And OK. View. Shaded with edges. And we need to make a correction. How to do this correction? Well, go to analysis and let's measure local radius, and I need to know, well, we can measure simple distance. Let's see if there's a radius here, or gallery, okay, or simple distance. Start point, okay. See, when I select this circle, it's starting on center, and when I select this face, starting on the center, okay, or let me see, okay, radius. Here we have measure distance, radius, and select this face and says 0.25. Okay, then go home, menu, window, go to skeleton, and double click on the sketch, last sketch, and see we have 0.4. So double click here and type 0.5, closed. This one has to be changed also, 0.2, 0.25, close, finish sketch. Since the assembly is referred to this circle, well, automatically if you change this, the assembly is corrected. There's no problem at all. So go to menu, window, assembly. You see the components are shown like this. So the weight, because the active part is the skeleton. So go to this part. You see, I'm moving to Assembly Navigator. Go to the name of the assembly, right click on it, make word part. Okay. So now everything is corrected. Save. Now we're going to start with the simulation. Okay. A way to hide the constraints, go to constraints, right click, unselect display constraints, and now the assembly is very clean. Save it, file, go to motion simulation, and now on the name, on motion navigator, on the name of the assembly, right click, new simulation, 01_motion, okay, cancel. Remember, avoid this motion joint wizard. Cancel. And then in show and hide the solids. Okay. And let's create the links. Link number one, it's this profile. All the reference lines. Center of mass, we use a circle. Center of inertia, circle. Okay, mass is 1 pound, 2, 2, and 2, 1, 1, and 1. As a parallel inertia moments and orthogonal inertia moments. And 0, 1 cam profile, or cam, can be cam. Apply. Then the next link is a follower, center of mass, the circle, center of inertia, the circle, 1, 0, 2, follower. Apply. Now we have the two links. Okay, it's done. And then let's create the joints. The first joint is revolute. So you touch this circle, it creates this direction. So we change the vector to the positive direction of y, display scale 3, and the join will be rev cam. The driver, as we have on our file, it's a constant of 0.5 revolutions per second. 0.5 revolutions per second. Okay? And then on the joint, which is a slider, I suggest you to touch this line in the zone inside this circle. Touch it. So it creates this vector and it creates this 3 coordinate system, or coordinate axis, excuse me. Display scale 1, it's okay. And CO2 follower. And okay. Okay, right. CO2 SLD from slider follower. Now the next step is just creating the curve and curve connection. Go to curve and curve. Touch this profile as a first curve, and very, very important, select second curve set and select this circle. You can say CO1 cam follower. That's okay. And last step is just only simulate the motion. Right click, new solution, 2 seconds, 100 steps. Make sure you have selected solve with OK. We can change it to CO1 solution and OK. That's okay. If it says redundant constraints, it's okay. Animation. We can see a front view. Play. And we have our cam simulated. Okay. On a geometric view, I really suggest you to select show and height, and in show and height, show the solid bodies. Okay. As you can see, if we continue simulating without the solid bodies selected, what you're going to have is only the skeleton moving. So what you need to do is go to links, double click on cam, select cam solid body, that's okay, and then double click on follower, and then select the follower, the shaft, the support, and then all of them belong now to the second link. Okay. If you want, you can hide the curves and sketches, and now you have the animation only with the solid bodies, which is much more real. Okay, we can have a frontal view. Okay, and then the final component is to show the displacement versus the angle. So we need to go to the layout. Okay, check layout. Layout settings. In this case, we're going to use a double view, side by side. Okay. And then select XY graphing, right click, new. The component that has to be analyzing is the follower. So go to CO2 slider follower, displacement, close, add a new curve, and said, okay, and this symbol, the viewport, is asking me where I need to place my graph. Okay, so let's simulate now, and then we have our full simulation. Okay, you see, this one is moving 2 inches, 0.5 inches, 2 inches, 0.5 inches. Okay. Okay, as you can see, this one is considering all the x values. So from the center, the maximum value is 1.5, which is the radius, okay, and 2, which is all the displacement. Okay, now it's important to know that in this case, we only have the connection in between curve and one curve. The next video, I'm going to show you how to use the mathematical displacement on this motion simulation. Thank you very much.